Okay, so today we will talk about passive systems. And for passive system, we will talk about the building envelope, the greenery system, and the layout design. Okay. So passive systems, passive design maximize the use of natural sources of heating, cooling, and ventilation to create comfortable conditions inside the building. So what does it mean by natural sources of heating? So like the sunlight is the source of heat. We have the solar heat gain through the windows, and natural sources of cooling. It could be the cool air. Okay, the cool air bring away the heat. And ventilation, so the natural air ventilation. So these sources can create comfortable conditions inside the building. Then we call them the passive design. It harnesses the environmental conditions such as the solar radiation, cool night air, and air pressure differences to drive the internal environment. Okay, so we have talked about sunlight, okay, cool night air. So in the daytime, it is hot, but there could be a temperature difference between the daytime and the nighttime. So just like these few days, in the daytime, it could be up to 30 degrees C, but then at the nighttime, maybe the temperature decreased down to 20 something. Okay, so in the nighttime, these cool air or the cool air temperature, the temperature difference between the exterior and the interior, it will be able to cool down the air. So we can, so that in the daytime we have some delay time for the exterior environment to transfer the heat to the interior. Okay, and here air pressure difference. So this is a kind of natural ventilation by making use of air pressure difference. So usually for a tall building, when there is a top opening on the high levels, and also openings in the low level, the air will naturally rise and then escape out of the building through the top level opening. So there will be a pressure difference. So these pressure difference will allow the air flowing naturally inside the building. Okay, passive measures do not involve mechanical or electrical systems. Okay, so what you have learned in the previous lectures, like I want to cool down the air, so I install the air conditioning system. Okay, I installed the chiller to provide the chilled water and flowing through the building and to cool down the air. So these are active system. The electrical lighting, active system, okay? But for passive system, we don't use these kind of mechanical fan or the air conditioning or the electrical lighting, okay? We make use of the natural resources. So this is opposed to active design, which make use of active building services system to create comfortable conditions, such as boilers, chillers, mechanical ventilation, electric lighting, and so on. Buildings will generally include both active and passive measures. So in practical, it is we cannot only rely on the passive system, just like our home, okay? Just like our home. I have windows at home, but I still need an air conditioner because in Hong Kong, in the summer, it is too hot and humid. So just rely on the natural ventilation may not be able to provide a comfortable air temperature or may not be able to provide the thermal comfort that you need. So we need to rely on the active system. So in practical, we have both active and passive system in the building. Okay, so when you want to incorporate passive systems, what are the considerations? So just like you are now the architect, okay, so you are designing a building and you want to incorporate as much as passive systems into your building. You want to make it a sustainable building. Then you will consider the building envelope, that is the wall, the exterior wall, the roofs. So these are the building envelope, and also including the windows. Okay, so the one wrap the building is the building envelope. And the building orientation and massing. So building orientation, whether the main whether the building or the windows, which facade is facing which orientation, which direction. So this is the building orientation. And building massing is about the thickness of the walls, whether you use thick wall or whether you use double glazing windows, or what is the form of the building. It is like a cube or a very tall building or a very wide building. Daylighting. Okay, so every building will have certain daylighting system. So it is to incorporate, it is to harvest the daylight, and then so in the daytime we can dim down the electrical lighting and to save energy. Okay, solar shading. So it is like a little bit in contrast to daylighting. For daylighting, we want to harvest the daylight. We want to allow the daylight coming in. But for solar shading is to block the sunlight. Okay, so usually, especially in the daytime, in the summer, okay, especially in the summer, we don't very much welcome the sunlight. Okay, sunlight is too hot, and even when it is not summer, sunlight may cause glare. Okay, it may be too glaring to our eyes. So if you have experienced reading opposite or reading next to the windows, and you have sunlight shining into the window, then it is actually not comfortable. Okay, so sunlight, we may want to block it. Okay, sometimes. And window and glazing. Okay, so window and glazing is part of the building envelope. So we want to make use of advanced window glazing system so that we can allow the daylight to come in, but maybe to block the heat. Material selection. So what would be the material of the building, whether it is constructed by a by steel frame or concrete, brick, or timber. Okay, green wall and green roof. So it is very popular nowadays to have the green walls and green roof. So not only for exterior, there are many green walls and features, green features inside the building. So like in the PolyU library, we have a small green walls inside the library, and then near P core and near core Q, we have a small green walls. So it is like a trend, okay? And but apart from the trend, the green walls and green roof can reduce the heat transfer from the exterior to the interior. It can filter the air. It can provide noise insulation. So there are many advantages for these green features. Okay, so today we will focus on these passive systems, and we will go through one by one. Building envelope. Okay, the building envelope is the interface between the interior of the building and the outdoor environment. So the envelope include the foundation. Okay, yeah, I forgot the foundation. The foundation is also a building envelope, and the foundation is the interface between the building interior and the ground. Okay, so if the insulation is not done very well, then there will be a heat transfer from the ground to the interior. But usually the ground has a delay of the temperature. Okay, just like in the summer, okay, the ground, the air temperature is hot, but the ground is still cool. And in the winter, when the air is cool, but the ground is still warm because the ground is a very big soil, and there will be a delay time of the heat transfer. Okay, so building envelope include the foundation, the roof, the walls, the doors, and the windows. So by acting as a thermal barrier, the building envelope plays an important role in regulating interior temperatures and helps determine the amount of energy required to maintain thermal comfort. Okay, so building envelope is very important because you can imagine if you have just like a box of ice, okay, you want to keep the ice not melt, you don't want the ice to melt inside the box, then you will use thicker box, insulate the box, right? So the building is the same. We want to keep the interior cool from the outside hot weather, then we want to insulate. Okay, to seal the wind. Okay, sometimes we may want to seal all the openings, and then we may want to use thick wall and so on. So this is the consideration about the building envelope. Minimizing heat transfer through building envelope is crucial for reducing the need for space heating and cooling. So in an extreme case, just like in the North Pole, they have the igloo, right? So the igloo has a so in the North Pole, of course, it is extremely, extremely cold. But inside the igloo, it could be not too cold. It's because it is made of very thick ice, and ice is actually a good insulator. Okay, so it is to minimize the heat lost from the interior to the exterior. So building envelope, whether it is made with insulation or what is the material, it is important for affect very much how much energy you need for the air conditioning. Okay, and the building, if you're interested in architecture, you will find that the buildings and different regions, different locations on Earth will have different characteristics. So just like in the hot climate, the building envelope can reduce the amount of energy required for cooling, and their characteristic could be something like this. So on the right, this is a picture of a house in desert climate. So in the desert climate, it is very hot in the daytime. So the thermal mass of earthen burn, so some like a soil, mud, adobe blocks, so and thick walls. So these building envelope helped slow heat transfer through the envelope to keep the interiors cool. So they will make use of thicker wall with good insulations, and they will have sun shading. So you can see these elves, these horizontal shadings. It is to block the direct sunlight. Okay, and on the left-hand side, hot, humid climate. The houses had big porches, deep eaves, high ceilings, and plenty of well-placed windows to encourage cross ventilation. So in this climate, the temperature may not be as hot as in the desert, okay, but it is also humid. Okay, so it is hot and humid. So you want the natural air to bring away the humid air. Okay, so they will have more windows so that they can allow cross ventilation and then more natural ventilations. In cold climate, the building envelope can reduce the amount of heat, the energy required for heating. Okay, so in Hong Kong, most of the time we are in the cooling season. Cooling season means that we want to cool the air. So in the cold climate, we want to heat up the air. So on the right-hand side, this is the igloo. So it is made of large bricks of ice, which are very good insulator with an outdoor temperature of negative 45 degrees, and igloo interior temperature can range from -7 to 16, right? So very impressive. It has the ice, very good insulator, and they are sealed. Even the door will be sealed. So it provides very good insulation from the exterior, extremely cold weather. Okay, on the left-hand side, this is these are traditional houses in Norway and Iceland, and they are made of turf, so some kind of mud, soil, which is cut from the ground and stacked on top of each other to form walls and roofs. So this is not just a door. Inside it is a house, and it is covered by the grass, the mud, by the soil, and these turf walls are much thicker than timber walls. So this provides extra insulations. So on top of the timber, they stack these kind of turf to provide extra insulation. Okay. So building envelope can significantly affect the amount of required lighting and HVAC. HVAC means the heating, ventilation, and air conditioning. So if the building envelope is designed well, then we can greatly reduce the energy spent on lighting and the HVAC system. So just like if you insulate your building well, like in the North Pole, okay, you have a building in the North Pole, okay, not too extreme. You have a okay, like in Malaysia, okay, in Malaysia the weather is very hot, and you want to reduce the heat transfer from the outside to the interior. So if you can reduce the heat transfer, then the air conditioning will need to spend less energy to bring away the heat. Okay, so for active system, we are working against the environment. So inside it is hot, so we spend the energy to take away the heat. So so the building envelope is very critical to the energy consumption on the heating and the on the HVAC system and the lighting system. And these two systems, the lighting and the HVAC, are the two largest end use of energy in both residential and commercial sectors. So in Hong Kong, especially for the HVAC system, or mostly air conditioning system, cooling system, it's constitute usually maybe around 20% of the energy consumption. So if your building envelope is designed such that you can reduce the heat transfer to the interior, then maybe you can minimize the air conditioning from 20 to 15%. The improvement of building envelopes have the potential to reduce greenhouse gas emission from new and existing building in the residential and commercial buildings. So energy or electricity, okay, for Hong Kong, the air conditioning system and the lighting system relied on electricity. Okay, so in order to generate electricity, we need to burn the fossil fuels. So in Hong Kong, apart from fossil fuels, we also have the nuclear power import from Daya Bay. Okay, but mostly we are still rely highly on the fossil fuels. And when we burn the fossil fuels, we are producing more and more carbon dioxide. And carbon dioxide is one of the greenhouses. So more carbon dioxide, then more and more man-made greenhouse effect. Okay, so by designing a better building envelope, reducing the heat transfer, then we can also reduce the energy consumption on those active systems. In addition, building envelope improvement also result in a variety of benefits for occupants, like lower energy bill, as well as improved thermal comfort, moisture control, and noise control. Okay, so for moisture control, noise control, thermal control, of course, we can also have active system. We can have like for moisture control, I can switch on the dehumidifier, okay? But if we can allow the natural ventilation to flow through, more natural ventilation to flow across the building, across the flats, the houses, then we don't need to rely on these electrical system, but still achieve a comfortable environment. So that's the target of passive system. Okay, another consideration for passive system will be the building orientation and massing. So first of all, let's talk about the building orientation. Orientation of building generally refers to solar orientation, which is the siting of building with respect to solar axis. So the solar axis or the sun path will be different for different locations in the world, on Earth, right? So in the lesson of BSE 1571, we have learned daylighting, and for the sun path, a location in the northern hemisphere will be very, very different from that in the southern hemisphere. And whether you are in the higher latitude, higher latitudes or around the equators will also have a very big difference in the sun path. So building orientation is how you will orient the building, whether the building it will be facing the southeast or other direction, and this will affect this will have an impact on the daylight availability or the solar heat gain due to the sunlight. So the building orientation can have an impact on the lighting, cooling, and heating costs. So if your orientation can help you to harvest the daylight, then you can reduce the electrical lighting, or if the orientation can allow you to have more, to have the solar heat gain in the winter, then you can spend less on the winter heating system, or certain orientation may give you more solar heat gain in the summer. Then if so, then you have to spend more on the solar, on the air conditioning in the summer. Okay, by maximizing suitable exposure, one can take optimal advantage of the sun for daylight and passive solar heating. Okay, I think for Hong Kong, passive solar heating is not really necessary in the winter. It is not very cold in Hong Kong, and in the summer it is very hot. So for most of the building in Hong Kong, we want to block the direct sunlight. But blocking direct sunlight means that we want to block all the daylight. Okay, daylight constitute sunlight, and also skylight. Okay, so we may want to block the sunlight coming at a high angle. Okay, but we want to harvest the skylight. And sunlight in the winter will be more welcoming. We welcome winter sunlight, but not summer sunlight. Okay, Sunpath in Hong Kong. So I think you should be quite familiar with this picture. So Hong Kong is located in the northern hemisphere. Sunlight comes from the south for most of the time. So if you remember the Sunpath diagram that we have learned, most of the time, almost the whole year, we have sunlight coming from the south. Okay, and in the summer, we have sunlight coming from the north for a short period of time. So in winter, the sun rises from the southeast and sets in the southwest. And in the summer, the sun rises from the northeast and sets in the northwest. So it means if you want more sunlight in the winter, then your building, largest facade, the window should be facing south. And if you want to minimize the summer sunlight, you may need to have some solar shading, some overhangs in the for the windows, and especially for the north direction. Okay, for the south direction, we may also use overhangs to block the sunlight coming from high angle. And usually in the summer, the sunlight will come at a higher angle. So higher elevation. Building orientation is an important factor in a building's thermal performance. The building form should be oriented in relation to the influence of the surrounding environment, including the sun's path and the prevailing winds. The prevailing winds, this is the wind direction for different seasons in a location. But this prevailing winds direction is only a general wind direction for a location. So like in Hong Kong, in the summer, usually the wind will blow from the south. Okay, we have the wind from the sea, and that's why it is humid in the summer. And in the winter, the wind comes from the north, from the land. And that's why we have dry, cool winter. Okay, so these are prevailing winds direction. But in Hong Kong, there are too many buildings. And therefore, these man-made landscape will also affect the wind direction. So we may need to study the microclimate around your building. Building orientation. So in order to maximize daylight harvesting and passive solar heat gain in the winter, the long axis of the build form should be oriented east-west so that the elongate sides of the building face north and south. So this is a recommended building orientation, a general recommendation for building orientations. So the sun will move across the east and the west direction during the day, and the winter sunlight comes from the south. So if you want winter sunlight, okay, usually in the winter it is cool, and when you feel cool, you want the sunlight. And actually, when you feel the sunlight, you will feel more happy. Okay? Usually, sunlight brings, will makes the occupants more cheerful, and it is psychologically beneficial to the occupants. So in the winter, we may want the sunlight shines into the buildings. Then you should have you should orient the longer side of the building facing south and to have the windows facing south. And for east and west, for east direction and the west direction, the sunlight will come at a lower angle, result in a high solar radiation. So if you want to minimize the solar radiation and heat transfer, then the shorter facade should be facing east and west. And how about the north? For the north, it will result in the summer sunlight, and we may use overhangs and some solar shadings to block the summer sunlight. But it also means that if the window is facing north, you won't have too much sunlight availability. But still, for the window facing north, although you don't have the sunlight, but you have the daylight. Okay, so the sky in the north is also a good daylight source, and it may also provide a high enough lighting environment without the need to switching on the electrical lighting. External shading should be used to reduce solar heat gain, the cooling loads caused by solar heat gain on the south facade. So south-facing glass is relatively easier to shade with an overhang during the summer to minimize the solar heat gain. So not only south, okay, for the north-facing glass, we may also use overhang to shade the sunlight. So just a short overhang will be enough to block the summer sunlight, because for the summer sunlight, for the north and the south facade, the summer sunlight usually comes at a high angle. So just a short overhang will be able to block the sunlight. But for the east and west direction, sunlight comes from lower angle, so it is much more difficult to block these low angle sunlight. Okay, windows on south wall can maximize sun penetration in winter, okay, because we are in the northern hemisphere. Window placed in the north wall allow diffuse light into the building and reduce heat gain. So for the window facing north, although we don't have the winter sunlight, but these skylights are good daylight source because it is diffuse. Okay, diffuse means it comes from all direction. Okay, comes from all direction. What I should. Okay, for diffuse light source means that the big area source. So for skylight, the whole sky is the light source. So it won't be very glaring. So unlike the sunlight, okay, sunlight is direct sunlight. So it will be comes from one direction. So it will be very glaring, very strong. But for the diffuse skylight, it comes from the very big sky, comes from different direction. So it is less glaring, but still it can provide a high enough lighting level. Okay, building form massing. Massing is deciding on the overall shape and size of the building. So whether the building is a tall or short building, long or thin, will it have significant cutouts? So like this layout, so you have a big cutout. So this is the cutout. Or here you have the cutout. Or it will be more solid, okay, like just a solid square. So this is more solid. So these cutout will enable you to have more windows, and the atrium or these cutout will be able to allow you to have more windows so that you can harvest more daylight, and you can also allow more natural ventilations. So compared to the solid, okay, compared to this solid building form, having cutouts can improve the daylighting and also the natural ventilation. So cutouts in the building footprint can provide daylight and enable cross ventilation. Okay. Using building masts or overhangs to create shade. So overhang, we know that we can use solar shadings, the overhangs to block the sunlight. You may also use the building itself to shade sunlight. So just like in the previous layout, so in this diagram, when the sunlight comes from this direction, okay, for example, then the building itself can provide shading to this facade. Okay, so this part of the building can act as a shading to the interior section of the building. Higher wind speed over tall buildings improve natural ventilation. Okay, so for taller buildings, there will be stack ventilation, and there will be comparatively more wind or ventilations. So in tall buildings, stack ventilation can be used to draw fresh air through a building. So top opening, open, and lower opening. Then the hot air will naturally escape out of the building through the top opening. In deeper buildings, atriums or courtyards can be introduced to allow light into the center of the floor plan. So atrium will be this example. Okay, this opening inside the buildings, this is called the atrium. So the atrium can allow daylight to enter to the interior of the buildings. So if this area is all windows or glazing, then the sunlight or daylight can enter to this center part of the building layout. Successful massing uses general shape and size of the building to minimize energy loss as much as possible, to maximize free energy from the sun and the wind. It is important to begin considering passive design strategies so that the surface area exposed to sun at different times of the day, building height, and the building width can all be optimized for passive comfort. So when we are determining the building form, what is the building form, whether there is a cutout or more solid buildings, and what is the shape building, we may use some simulation software to simulate the energy intensity. So just like in this diagram, option 1 is a more solid design option. And then option 2, a more elongated building form. So they can do a comparison. Okay, and then the energy intensity is found to be higher for option 1. Okay, so this is just an example. So this building form is rather simple, but in practical, the building form, it will consist of different kind of shadings, and the layout plan will not be that regular, so it will involve a large amount of energy simulation and process. But after that, we can have a better idea about how this layout and the building form can affect the annual energy consumption of the building. Okay, daylighting. So we know that the orientation of the building can affect daylight, the daylight availability, and the word daylighting means the lighting, the system to harvest daylight. Okay, lighting provides the opportunity for both energy savings and improved visual comfort. Okay, so by utilizing daylight, we can save electrical lighting. We can dim the electrical lighting, or we can switch off the electrical lighting. And apart from the advantage of energy saving, another advantage of daylighting is that the visual comfort. Okay, daylight is the best light source. So it is a full spectrum light source. Full spectrum means daylight consists of all wavelengths, and we humans are designed to live under daylight, not the fluorescent or the LED. Okay, so under the daylight, we are most healthy. So we should not stay indoor all the time. We should expose to the sunlight, to the daylight. And daylight is flicker-free. Flicker-free means that for the fluorescent lighting, for the LED lighting, actually they are flickering at a very high frequency so that we cannot perceive it. But for light, it is flicker-free. Okay, and it has the best light quality in terms of the color, in terms of the color rendering, the color temperature, the appearance, and we feel more happy when we have the daylight and also the sunlight. So with proper integration of well-designed artificial lighting system, daylighting can offer significant energy savings by reducing a portion of electrical lighting load. So electrical lighting usually constitute around 10 to 12% of the building energy consumption. And although it is not too much, but for lighting system, it is rather comparatively easier to save compared to the air conditioning system. So by some lighting control like photo sensor or occupancy sensor, we can dim down or switch off the lighting when it is not in use, or when the lighting level is adequate. Okay. So in this figure, we have a daylight sensor. So it can monitor the lighting level on the desk, and when the lighting level is high enough, then the lighting sensor will send a signal to the luminaire, to the lighting fixture, so that it can dim down, dim 10% or 30%, 50%, and so on. Okay, an extra benefit for utilizing daylight is the lowering of cooling load due to the reduction of heat gain from electric lamps. So lighting system is a heat source in the building. Okay, so for the air conditioning system, apart from cooling the interior due to the heat transfer from the outside, the air conditioning system is also cooling the air due to the cooling or reducing the heat due to the heat gain internally in the building. So inside the building, we have many heat sources, like we human. Okay, we human are one of the heat source in the building, and there are many equipments in the building. We have the computers, we have the fan, we have the maybe some cooking appliances, the televisions. So these are heat source in the building, and the lighting system, apart from providing or a lighting system will output light energy, but actually it will also gives out heat. So the amount of heat given out from the lamp or from the lighting system will depends on the lamp, whether you're using fluorescent LED or incandescent lamp. So in this picture, this is a incandescent lamp, and incandescent lamp is a very inefficient light source. So more than 80% of the electrical energy is in fact converted into heat. So these heat will need to be brought away by the air conditioning system. So when we reduce or when we turn off the lighting, apart from saving the electrical energy spent on the lighting system, we are also saving the air conditioning system energy for bringing away the heat from the lighting. Okay, and in addition to energy saving, daylighting helps create visually pleasing and productive environment for building occupants. So more productive. So here means that when an office incorporate daylight compared to an office without any windows, no daylight, the office with daylight will be more productive. And the same apply to the shopping center. So when a shopping center incorporate daylight, it will give a more cheerful atmosphere to the buyers, to the customers, so that the lighting can put them into a buying mood. So they will be more happy to spend money inside a shopping centers with daylighting. Okay, simple daylighting system consists of just an aperture. So just a hole, a window to let the daylight reach the building interior. The aperture can be on the top of the building. Then we call it the top lighting or the roof light, okay, skylight. Or the opening can be on the side of the building. So we call it the side lighting through windows. The aperture is usually glazed, but can also be unglazed. So it depends on the window design. Okay, advanced daylighting system. So when we have a windows, the area near the window will be very bright. So that area will usually has a depth around 2 times of the window height. Okay, 2 times of the window height. So it means when the window has a height of h, then the area where you can utilize daylight is around 2 to 2.5 times of h. And in the deeper part of the interior, because it is too far away from the window, then those far away area, the deeper area, may not be able to enjoy the benefit from the daylight. So in order to increase the lighting level in the deeper part of the building, we may make use of light shelf. Light shelf is a horizontal surface that reflects daylight deep into a building. So light shelves are placed above the eye level. Okay, so this level is higher than our eye level, and it have high reflectance on the upper surface. So on this upper surface, it is very reflective. Okay, white color, very reflective, so that it can reflect daylight onto the ceiling. And then when the ceiling also has high reflectance, white in color, then it can reflect it into deeper part of the building. And for the occupants near to the windows, sometimes the sunlight can cause discomfort, maybe due to the glare, maybe due to the heat. Then even when he drawn the curtain, daylight can still be emitted into the interior. Okay, so light shelf is a lighting system to allow daylight to enter to the deeper part of the building, of the interior, so that it can reduce the electrical lighting energy. Okay, another day lighting system is the light pipe. Light pipe system consists of a daylight collector. So this is the opening maybe on the rooftop of the building. And then they have the transmitter. Okay, this is the transmitter to transmit the sunlight, the daylight into the emitter. Okay, this is the emitter. So this emitter is just like an ordinary lighting fixture mounted on the ceiling, or maybe sometimes on the side of the wall. The transmitter transmits daylight into the interior, and the emitter distributes daylight to the interior. So in Hong Kong, we also have a light pipe in the Zero Carbon building in Kowloon Bay. So if after the coronavirus, after everything is settled, when you have time, you can pay a visit to the Zero Carbon building. Okay, let's take a break of 5 minutes, and then after that we will finish the lecture.